Hi everyone, welcome to the classes on engineering mechanics. Today we will be discussing about projectiles. We have already studied the projectiles during year plus 2, so we will discuss some problems regarding the projectile. And before going to that, we will be discussing some initial terms connection with the projectile. First one is the trajectory. That is the you can see a projectile path. That is a path traced by the projectile during its motion. Suppose we have thrown some objects to the air. It will move along some path. The path traced by the projectile during the motion is called a trajectory. And the second name is velocity of projection. So the velocity by which, that is termed as u, velocity by which we will be throwing the object to the air is called u. And it will make an angle with the horizontal, that is called the angle of projection. And the next one is the time of flight. So after we are releasing the object, up to what time it will remain in air before hitting the ground, that is called hitting the ground or hitting the target, that is called the time of flight. And the last time is the range. Range means how much distance, horizontal distance is covered after release and before hitting the target. How much horizontal distance is covered. Suppose we are releasing the object with a velocity u, we will have two components, u sin alpha and u cos alpha. And we will be simply using the equations of linear motion, that is velocity u is equal to v plus at and u square minus v square minus u square equal to 2as s is equal to ut plus half at square. We will be using these three basic equations and we will be formulating based on that equation. Okay, first of all we will see the projectile motion of a object that is released horizontally from a certain height. So suppose we will be releasing a missile from an aeroplane, or we'll be dropping some object, we'll be throwing some object from the top of a building, like that. So it will have only horizontal component of velocity. The vertical component of velocity will be normally it will be 0 at the initial while releasing. So but as the object moving forward, the vertical component will be increased. So you know the reason, because the earth will be giving an acceleration of g on the object. So initially at the point A, when the object is released, its downward velocity is 0. It will have only horizontal velocity. As it moves along the path, the object is now free. Now it will be affected by the acceleration due to gravity. So its velocity will be increasing in a range that v is equal to u plus at, where u is the initial velocity in the downward direction, it is 0, and a is the acceleration due to gravity, that is minus g, and with respect to time it will be increasing. So while reaching the point B, it will have both horizontal and vertical velocity. Its horizontal velocity will be v and vertical velocity will be given by u plus at. Okay. So based on that we have to do some problems. So this is our problem. An aircraft is moving horizontally at a 108 km per hour. Normally we will be dealing with a meter per second. To convert into meter per second, multiply it by 5 by 18. So we will get a 108 into 5 by 18, you will get a 30 meter per second at an altitude of 1000 meter. That is, the aeroplane is at a height of 1000 meter towards the target on the ground. That is, an aircraft is horizontally release a bomb which hits it. Okay, the aircraft is released a bomb from a height of 1000 meter. Okay. Estimate the horizontal distance of the aircraft from the target. You are asked to find this range. So at point A, they are releasing the bomb. The aircraft is moving at 108 km per hour, that is 30 meter per second. It is the velocity, that is the v is given as 30 meter per second. So after releasing, after some time, it will hitting the point B, and it is given h is equal to, it is given as h is 1000 meter. Okay. So for completing a distance of h, how much time it will take if it is released from a velocity 0 to travel a vertical distance of h, how much time it will take, that we have to find out. Okay, estimate the horizontal distance of the aircraft from the target. They are asked to find out the range and also calculate the direction and velocity with which the bomb hits the target. The bomb is released with a velocity 30 meter per second. Initially it don't have any vertical component, but while hitting it will have both horizontal and vertical component. Horizontal component will be same as the released velocity 30 meter per second, but vertical component initially it is 0, but it is increased to some value, and it is given by the time of flight, how much time it will take to reach the point. So it will be calculated. First of all, we will write the equation for S is equal to ut plus half at square. For traveling a distance of 1000 meter from an initial velocity of 0, how much time it is taken? So from that we can calculate the time of flight of the object. So initial velocity is 0. We're traveling in a downward direction. Initial downward direction velocity is 0. So we have substituted u is equal to 0 and ut it will be 0 plus half at square. So where a is the acceleration due to gravity, we can calculate the value of t. That is the time of flight of the object is given by 14.3 seconds. So for a time duration of 14.3 seconds, the object is in the air. So with this 14.3 seconds, the object can travel a distance of O to B, that is OB, that is called the range of the object. So with this time duration 14.3 seconds, it will have a velocity 30 meter per second in the horizontal component. So it can travel a distance of 30 into 14.3, that is 429 meter it can travel in the horizontal direction. So the horizontal range is given by 429 meter, that is horizontal component of velocity into time taken. So our first part is over, that is the range, estimate the horizontal distance of the aircraft from the target. That is our 429. Next we have to calculate the direction and the velocity with which the bomb hit the target. So while hitting, it will have a horizontal component of 30, it will have a vertical component. The vertical component can be calculated by v is equal to u plus at, and u is equal to 0, we have to multiply a acceleration into time. So acceleration into 14.3, which will give the final velocity 0 plus 9.8 into 14.3. 140.1 is the final velocity, vertical component of velocity with which it will hitting the ground. Okay. The angle which is the bomb makes with the vertical when it hits the ground, its component will be like this. This is the angle made by the component, which is given by horizontal component divided by vertical component. Tan theta is equal to opposite side by adjacent side. Tan theta is equal to opposite side is the horizontal component and adjacent side is the vertical component. So horizontal component is equal to 30 meter per second, vertical component is equal to 140.1 meter per second. So from that we can calculate the angle theta. Okay, and we can calculate the magnitude of the resultant velocity by taking horizontal square in plus vertical square and taking the square root. We will get the resultant velocity of the object as 143.3 meter per second. Okay, we will go to the next problem. Here you can see a motorcyclist is jumping from a height of 2 meter and crossing a depth of 4 meter wide, crossing a channel of 4 meter wide. So we are asked to find out the necessary minimum velocity. What should be the velocity of the motorbike to cover a distance of 4 meter? Okay, we can compare this question with our previous question. In our previous question, we have given 1000 meter height and we have calculated the time. The same way, we will be starting it. Initial velocity in the downward direction is 0 and it has to travel a distance of 2 meter. So we will calculate the time duration. And we are applying the time duration for the horizontal distance also. We will be calculating the velocity. Okay, so you have to complete this as a homework. Okay, we'll go to the next question. An aeroplane is flying on a straight level course at a 200 km per hour. Again, it will be kilometer per hour. You have to convert it to meter per second at a height of 1000 meter above the ground. Okay, and an anti-aircraft gun loaded at the ground fires a shell. The initial velocity 300 meter per second. So its u is given as 300 meter per second. When the plane is vertically above it, at the time of firing, the plane is vertically above it. Okay, at what inclination to the ground should the gun to be fired to hit the plane? The plane velocity is given, bullet velocity is given. So we have to calculate the angle at which the gun should be fired to hit the plane. Okay, so we are asked to find out the angle by which the gun should be fired. So the gun is fired with an initial velocity u and it is having an angle alpha. So it will travel a distance AB. It will travel a horizontal distance AB to hit the plane. At the same time, the plane will also travel a horizontal distance AB by the time. So plane velocity is given 200 km per hour. We will be converting it into meter per second. By multiplying it with the time, it will get the horizontal distance AB. And again, we will have the initial velocity u is given as 300 meter per second. We will have its horizontal component as u cos alpha, and we will be multiplying with the time. Again, we will get the same distance AB. So we will be comparing these two. We will get the angle alpha. So we will be writing the plane velocity in meter per second. We will obtain 55.56 meter per second. The height of the plane is 1000 meter. Velocity of the shell is 300 meter per second. Alpha is the inclination of the gun, and t is the time taken. The velocity of the plane is 55.56 meter per second. The distance traveled by the plane by a time t is 55.56 into t. And at the same time, the horizontal component of velocity of the shell, that is the gun, it's given by u cos alpha or 300 cos alpha. The distance traveled by the gun is given by 300 cos alpha into t. To hit the bullet on the plane, the distance traveled by the plane should be equal to the distance traveled by the bullet. That is horizontal distance. Horizontal distance traveled by the plane should be equal to horizontal distance traveled by the bullet. So we will be equating these two. We will obtain the value of t. Not obtain the value of alpha. Okay. So alpha is given by 79.3. So our first part is over. The second thing we have to calculate the how much time after the firing the gun will hit the plane. The next thing we have to calculate the time for hitting the plane. So we will get the vertical component as 300 sin theta. So we got the angle as 79.3. Our vertical component is 295 meter per second. And we have to travel a distance of 1000 meter because the plane is at a height of 1000 meter. So we have to travel a distance of 1000 meter. We will be applying the equation S is equal to ut plus half at square. So we have the vertical component as 295 meter per second initially. So we will be applying ut, that is 295 into t, minus. After firing, it will be affected by the acceleration due to gravity. So its velocity will be decreased. So minus half at square, that is minus half into 9.81 t square. So we will get an equation for quadratic equation. By solving this, we will get the time for 3.57 seconds. The next thing we have to calculate the what will be the horizontal distance of the plane from the gun. Again, they have asked the distance AB. We have already wrote two equations for AB, 300 cos alpha into t or 50.56 into t. Substitute in any of the equation, you will get the value of horizontal distance as 198.3 meter. So these are the basic questions of projectile. They are using the equations of linear motion, that is S is equal to ut plus half at square, and V is equal to u plus at, V square minus u square equal to 2as. By using these three basic equations, we can solve all problems of projectile. And they have formulated some special equation for the projectile from this equation. Even though we are skipping that equation, from the basic equation, we can solve all the problems of projectile. So we will be discussing more problems in the coming classes. Thank you.